Hello everyone, welcome to the video lecture series of Cryptography and Network Security. I am your instructor Dr. Ramesh Prajapati, and today we are going to learn the secure hash algorithm, and it is also called the SHA-512. So let's start with today's agenda. The first overview of secure hash algorithm, steps of SHA-512, message digest generation using SHA-512, and the last is SHA-512 processing of a single 1024-bit block. So let's start with the first topic, the overview of the secure hash algorithm, and it is also called the SHA-512. So the first question in your mind, why we use secure hash algorithm? So as in the previous two sessions, we have already seen the hash function, right? So when we apply the hash function on a plain text message, so after applying the hash function, it's generating a fixed length of code. So here, how to generate this fixed length of code? So with the help of SHA algorithm, we will generate the fixed length of code, and with the help of fixed length of code, we have to identify if the sender and the receiver is an authenticated person or not. So let's start. The first is h equal to h of m. This it means that the small h it represents the fixed length of value equal to h of m. M it represents the message, and capital H is represent the hash function. So the first we have to apply the hash function on the plain text message. After applying the hash function, it generating a hash value, and this hash value, it is also called the fixed length of code or message digest or the hash code. Now the next, the SHA algorithm, the plain text is processed in the terms of block, and the size of the block is the 1024 bits. And the total number of steps are 80. It means that the 0 to 79 steps are considered in the SHA algorithm. The next is, in each and every round, the keyword is used, and the size of the keyword is a 64 bit, and the keyword is generated from the plain text message. And in each and every round, we are considering the constant and the buffer. The constant is represented as a k, and the constant is filled with the random number, and it represents in a hexadecimal number. The next buffer is it stores the intermediate result and the hash value of the hash code. The next, how many buffers we have required? As you know that the size of the hash code is a 512 bits, and the size of the buffer is a 64 bit. So I will divide this number, the 512 by 64, you will get the 8. It means that we have required the 8 buffer. Then the output of the first block will be given as an input to the second block, and the output of the second block is input to the third block. So till the end, the same chain process will be continue, and the output of the last block is called the hash code. Right? Then these all are the overview of the SHA-512 algorithm, and let's start. What is the input of the message? It means the size of the input message is 2:128 bits, and generate the output as a 512 bit message digest or hash code or hash value, and the input is processed in a 1024 bit block. It means that we are input 1024 bit block and process that block. So let's see the various steps of SHA-512. The first step, 1, append the padding bits. It means we have to add the paid so that the length of the message is multiple of 100 1024 bit. So the message is padded so that its length is congruent to 896 modulo 1024. It means that in a 1024, subtract the 128 bit, so you will get the 896. Now the padding is always added even if the message is already of the desired length. It means that the message is less than 1024 bit. Again you have to add the padding bit, and the next is the padding. What is the size means how to add the padding bit. So the padding is consist of a single 1 bit and is followed by the necessary number of 0 bit, and we can consider the length of the plain text is 128 less than the multiple of 1024 bits. The next is we can consider the second step. In second step, append the length. It means we can represent the original plain text message is in 128 bits. So append the 128 bits in a plain text message so that such that the length of the message should be the multiple of 1024 bit, and the block contain the length of the original message before padding the bits. So here, based on this step 1 and step 2, we achieve the length of the message. It should be the multiple of 1024 bit. So let's take one example to clear the step 1. What is step 1 and step 2? So here we are considering one message ABC. ABC is one message, and we have to represent the binary value of ABC is 0110001, B is 011001110, and 0010011. So this is the representation of your binary representation of your ABC message. Now the length of this message is a 24 bits. So it is stored in a I. This I is equal to 24 bits. It means the first step we append a 1 followed by 0 bits. So where the k here, the k is determined. How to determine the k? It means that if I want to add the padding bit, so how I can add it? So we append a 1 followed by k equal to 8710 bits, where the k is determined by how to find the k. So the k equal to the 896 minus I plus 1 equal to 896 minus 25, because the length of the I is 24 bits. So we subtract this number from the 896, you will get the 871 mode 1024. It means that we have to add the 8710 bits as a padding. This is the first step. In the second step, finally we append the 128 bit value which contain the binary representation is I equal to 24, decimal number equal to 11002. It means the binary representation, and the padded message is then given like this. The padded message is like this. First we have to describe our message ABC, then we have to append the bit and the length of the bit. It means that after step 1 and step 2, we appended the bit and the length is also appended, and the message of the appended bit, the length of the message, it should be the equal to the multiple of 1024 bit. Now in the step 3, in the previous 2 steps, we have represented the length of the message. Length of the message is multiple of 1024 bit. Now in this third step, you will see the initialization of hash buffer. So the expanded message is represented as sequence of 1024 bit block and the block is defined as a m1 m2 up to 7mn. So the total length of the expanded message is a n cross 1024 bit. It means that in this figure you can see, in this figure the 1024 bit, it means that the message m1 m2 and m up to 7mn, it is represented as a message block of message, and the size of this block is 1024 bit. In the second step, in the buffer is stored the intermediate and the final result of the hash function, and the buffer is represented as a 8 and 64 bit register. It means that the A to H at the 8 buffer, and the size of the buffer is a 64 bit, and this hash buffer is represented in a hexadecimal number. And here we also initialize the hash buffer with the help of initialization vector, and initialization vector it filled with the random numbers. Then the next is, we have already seen here your message is divided into the fixed size of block, and the first block is m1 and its size is a 1024 bit. Second block m2 and its size is a 1024 bit. Now in the step 4, the step 4 process message in a 1024 bit block. It means that here one module that consists of 80 rounds. It means that here we are considering the 80 rounds, and this module is labeled as f function. You can see in this figure this f represents the function. And in step 5, it is output after all nth block of 1024 bit have been processed, and the output from the nth stage is 512 bit message digest or message code or message or hash code or hash value. So here you can see in this figure the total is n cross 1024 bits of the length of the message, right? And after applying the function, it generates the hash value. So this is all about the step. Now in the next we will see in each and every round how the function will be used. So let's see we added the we have to add the pairing 1 followed by all zeros, and after that we representing the 128 bit, representing a 128 bit. So the length of the message is a multiple of 1024 bit. Now here the first block m1 and the size is a 1024 bit. So we apply the first block 1024 bit in the function, and in another input initialization vector, and it which is called the buffer, and the buffer is represented as h0. Then after applying the addition, it generates the hash code, and the first block of hash code, and it represents the h1, and the size of the hash code is a 512 bits. Now the output of the first block will be given to the second block, and we will do the same process. After applying the addition, it generates the second block of plain text, second block of hash code, and it represents the s2, and the size of this is a 512 bit. Repeat this process until the final block will be generated, and the final block, the output, the final block, the size, final block of hash code, the size is the 512 bits. So this is all about the message digest generation using the SHA-512. So this is the simple overview of how to use the function in each and every round. The next in this figure, first of all, in the before going to see this figure, in the previous two slides we have generated the buffers, and the buffer is A, B, C, D, E, F, G, total 8 buffers, and the size of the buffer is a 64 bit. Now, in each and every round, we have to require some input. So, what are the input will be considered? So, in each and every round, we are considering 3 input. First input is W0, means word which we are generating. Then the buffer A, B, C, D, E, F, G, and the next is a K0. K0, it means it represents the constant, right? So we input this we are inputting 3 things in the round 0. After applying the round 0, the output of the round 0 will be given input to the second round, right? So it means after completion of round 79, the initialization buffer is added with the output generated after the round 79, and after doing the addition is represent the addition of modulo 2 raised to 64. After applying this, it's generating a hash code, and the size of the hash code is a 512 bits, right? So this is all about the SHA-512. Then here you can see in this figure you have to require 3 input. First hash function buffer A, B, C, D, E, F, G. Then W0 is the second input. W0 represents the word, and the next input is K0 is represent the constant, and the output of the round 0 is will be given input to the next round. And after completion of round 79, we will input word W79 and the key constant K79, and after applying the round 79, it generates the output, and in this output we apply the initialization vector and apply the addition on that output generated from the round 79, and initialization vector it generates the hash code, and the size of the hash code is a 512 bit. So I hope you clear this idea.